from the center to the edge of the circle. If you continue that line over the other side, that is a diameter. A line that goes from one side of the circle to the other, but doesn't go through the center, is called a
sector.
Chord, yes. Oh, okay. A line that just touches off the circle at one point, I know mine just mightn't look like it, is called a tangent. So this is a tangent. This is a chord. Okay. This is a diameter, or from here to here is a radius. Okay, what ones have we not dealt with?
The third one,
the blue line. Oh, it's a radius. That's a radius, yeah. So a sector then is like a slice of it. Yeah, so a sector is this. So it's got two radiuses. And a segment then is any other area that a chord makes, which is not used very often. Okay?
Sector, where's sector?
Yeah, this is sector. Okay? Okay, so we're going to be using these from now on, so yeah. Oh, yeah, sorry, I don't have arc there. Arc is this distance here is arc. Arc is that distance. Yeah. The length of an arc, it's a part of the circumference, is an arc. I didn't say that one. Yeah, and if you have this is called a segment. If you have an area, the chord is the line, the segment is. Okay, so we're going to be using these in a number of circle theorems. There's a bit like when we do transversals, we create a bunch of different names for certain types of angles that are created. And that is also going to happen when we draw some shapes inside circles, so triangles inside circles, quadrilaterals inside circles. What happens with a tangent? What relationship does it have with the center? And things like that we're going to look at now. So I presume we're ready to go.
Yep.
Okay, let's start with the first one. Okay, so the first one we're going to look at is the angle in a semicircle. So the angle in a semicircle is 90 degrees. This is the bit I'm going to try not to rub out what I write here. So if we create a semicircle, so a semicircle will have to go directly through the center. If we create a semicircle and then we make a triangle with that anywhere, so make a triangle here like that. This angle up here is 90 degrees. That's it. That angle will always be 90 degrees. So in all these examples we have here, I know that this angle will be 90 degrees, this angle is all 90 degrees, and this angle here is 90 degrees.
That's a semicircle?
Yes. So yeah, I have, like, if I remove this half of the circle, it'd be a semicircle, yeah. Yeah.
So the angle touching...
The angle touching the edge of the circle, yeah. That's not part of the diameter. So this is the diameter across here. So a diameter is drawn. The other angle then is a right angle. And that's it. Okay, moving along. This is kind of a follow-on. The center of a circle is twice very long way of saying something. This is called the arrow rule, if you want to remember it that way. So we have a circle. We make an angle at the center. So we make this angle here. We're looking at that angle. And then if we use the same arc, so this same 2 points here, and we make another angle using those same 2 somewhere else on the edge of the circle. So I've created 2 angles now using these 2 points. One to the center and one somewhere else on the edge. This one is twice this one. Yep. So I'll draw it again. I'll redraw this. So we have a center of a circle, and we have an arc created off that. So we have this is an arc distance. These 2 points are where we're going to start our angle. We're going to look at this angle. If I draw another angle using these 2 points, but not to the center, to the edge of the circle now, so I'll just go up here. If I draw those 2 lines to the edge of the circle this time, this angle in here is twice this angle. So if this one is 100 degrees, this one's 50 degrees. So if this angle is theta, this one is 2 theta. It's sometimes used. So I'll draw a second example. So you just, no matter where you do this thing, sometimes it crosses over. So the more difficult questions is if I put the other point over here, so it's going to look complicated in a second. I'm going to use this point. This is the center angle. And maybe just change colors just to show. This is the one that might look a bit weird. If I join to that point.
Wait, why are you joining to that point?
Any point. If I join to any point, the one at the edge, this one, is going to be half, the blue one is going to be half the black one, yeah. Or the red one now, but. So it doesn't have to be, so it always makes this shape. It can go in a weird direction as well. Yeah. Yes, it has to be starting at the same point. Notice the way these lines are starting at the same point. One goes to the center, the angle goes to the center, and the other one goes to the edge somewhere.
What do you mean? Oh, like the line goes to...
Yeah. So maybe I'll do it. If I do it again, if I just do it anywhere, so I'm going to pick these 2 points. I'm going to make an angle to the center, and then my third point I might put over here. I'll make that angle to that edge, and now that this angle I've created is double this angle over here. So you can keep, I'll do that again. This is the one that maybe visually can be a bit weird looking. If I pick any 2 points on the edge of the circle and think about the center, if I make that angle at the center, so I made an angle here. Then I pick any point around the outside of the circle. So let's just go over here this time. And using these same 2 start points, make an angle, make a triangle if you want. This angle here, the first one I created to the center, is twice this one over here.
How does somebody find that?
What if you made the angle in the arc? Would that not work?
It will, yeah. It will work.
It would work. So if you made like a little diamond.
Yeah. Because I have to add to 180. Okay. All right, so we can see a bunch of these. This is, I think, the example you're thinking about, Ozzy. Like this?
Yeah, like that.
Yeah, so this one's going to be half. Half of this one. Half the one on the other side.
What are you dressing up for? Wait, Mr. Connors, what are
Yeah.
you dressing up as?
Oh. Let's go to the next one then. So the bow tie rule are angles subtended by the same arc. So you call this the bow tie rule. So angles from the same arc. So we're dealing with the same arc again, but this time our angles are not going to the center. They're going somewhere, they're both going to the edge. So if we start with the same two starting points, bring it somewhere to the edge, then I use the same two starting points again and go somewhere else on the edge. The two angles I've created up here are equal. This angle to the edge is equal to this angle to the edge. It's kind of a continuation of this one. This time we're not going to the center. We're going to the edge twice.
I feel like the rule you wrote doesn't really make me understand. Angles from same arc. Is that
Bow tie?
is that the rule?
The angles from the same arc are equal. Sorry, I didn't finish it. It's called the bow tie rule because it kind of makes a bow tie. I'll do another example of that. Start again. Pick 2 points on the edge. So this bit, this between here and here is called the arc. So 2 points on the outside. If I go anywhere on the outside with my next point, and I make an angle with the original 2, that's one angle created. If I do it again, just pick another point over here and use the same 2 starting points and go back to this angle is the same as this angle. Now it mightn't look like in my diagram, but it is.
What's the point of this?
What's the point?
Yeah.
You'll use them to problem solve soon. So the point of it, a bit like anything in maths, it's logical processing. Maybe at another time, if we've time before the exam, I will go through how each and prove them, which takes a while, but you don't need to learn how to prove them. I want this to be a video you can look back on and go explain each one. So try and bear with me, Kayleem, and make it a good...
I didn't want to really mean, I was just wondering.
Yeah, but the last time you asked me about my costume, so you're not really helping. Thanks. Okay, next one, cyclic quadrilateral rule. Let's spell cyclic right. So there's 2 main rules here. So what is a cyclic quadrilateral, first of all? Cyclic, circle, quadrilateral, we just have any 4 positions on the outside makes a 4-sided shape, and that's a quadrilateral. Not going through the center, just in general. The opposite angles are supplementary. So the opposite angles, this angle and this angle, so angle A and B, are supplementary. What does that mean?
Oh, they're the same.
No. Opposite angles add to 180. So A plus B equals 180. Supplementary. Now this is kind of a follow-on. That's the main part. The second one is if I continue on a line here, what angle would that be equal to? No, yeah, the 2 of them together, but this one in particular, the exterior one, it'll be equal to A, yeah. This one will be A as well. Because if the 2 of these add to 180, then this is a straight line. This also adds to 180, so if this one's A, this one has to be A too. So the exterior angle is equal to the opposite interior. This one and this one are the same. So there's 2. The main one here is this one comes up more. The opposite angles add to 180. These 2 add to 180, and these 2 add to 180 degrees. Okay, some examples here. So on this one, y will be 110, because 70 and 110 make 180. X here is going to be 88. Yeah, very good. Okay. Okay, so we had tangents earlier on in one of our initial diagrams. So let's look at tangents. Let's call this one tangents of the circle. Okay, so if the first one, from an external point. Okay, so we have a circle. We have some external point down here, external, outside the circle. If we make a tangent that starts at this point, so a tangent to the circle, it could only really go two directions, yeah? To make a tangent, it would have to go this way, somewhere up here like that. Oh, that's very badly drawn. This way can make a tangent, and one drawn this way make a tangent. Try and make your diagrams better than mine. So they both just touch off once, here. That the distance where it touches, here and here, these two distances will be the same. The distance from here to this point where it touches the circle, and here to this point, will be the same. So distance 1 and distance 2 will be the same.
Can you write that in word form?
It's written there.
Oh.
Tangents from an external point are equal in length. I'll write it. Oh, I already have the start of it. Are equal in length. My writing's very messy. Okay, and then the second part of this one, if I do have a tangent to a circle, let's just say I have one, I'm only looking at one at the moment, and you draw a line to the center of the circle from it, this creates a right angle here. Always. If we have a tangent to a circle, we just draw a line to the center. So if I drew a line here to the center, this line is at a right angle. Okay, so but it's on this there. So this is called the radius tangent. It creates a 90-degree angle. So if you draw a radius, so radius has to go to the center from a tangent, it creates a 90-degree angle. So it often comes up in this kind of shape, where this is 90 degrees, then if you can make some sort of quadrilateral out of that. That's 90 degrees as well, that's 90 degrees, so sometimes they talk about these two angles, because these two distances are the same. You can do some working out there. This is also two isosceles triangles, if you cut it in two. That comes up a lot. Yeah, so you can see in this one on the right, the more difficult looking one, this is going to be a right angle here, and this is going to be a right angle here. So that will help, and then you can find y a lot easier once you know that this is a right angle. You know that this angle is double this angle. This is a right angle because this is a tangent. Yeah, and then this is a radius. Yeah. Z. Not sure about that. No. Yeah. Yeah. It's not like a. It's not an isosceles. It's okay.
So you could find y, right? So y would be 100 and
Well, to find y, I probably 90, 90, 48, and then you'd have the center one, and the center one's double that one. Once I found y, I know this one as well, because these two have to add to 360, so I can find z. That's.
You can just do a quadrilateral.
Oh, you can do quadrilateral as well. Yeah, yeah.
But that's smart. I like that.
Okay, We'll try and go through all these examples in a minute to get all the answers. I just want to get the theories done correct first. Okay, next one. Number 6. Number 6. Bisecting a chord. A perpendicular from the center of the circle to a chord. A perpendicular from the center of a circle to a chord. So if I draw a chord, if I draw a perpendicular line, right angle, it bisects. So it cuts it perfectly in two. Mine doesn't look great, but the example over there looks better. The perpendicular from the center to a chord, so a chord is any line that doesn't go through the center, bisects the chord. So bisect, cuts in two. Cuts perfectly into the chord. And then usually creates this nice isosceles triangle type thing, because this is a radius and that's a radius, so they have to be the same length, and then there's lots of things that can come off that. So you see in the exam, almost certainly you're going to get like a paper, your paper 2, so your non-calculator paper. You're going to get something like this. And it's like, yeah, find y and z, where you have to use 2 or 3 different circle theorems to find the unknown angles. We'll look at these questions in a minute. I just want to get all the theory on the video first, so you can watch it back later if you're stuck. That's that one. This is the last one, I think, which is great. Last one. Alternate segments. Okay, so it's about bringing in a tangent to a triangle. So we got a tangent here. I want to make sure I draw it similar to the one on the board. That's a bad last line.
Sure.
Yeah.
What does that say in the brackets?
Cuts in two perfectly. Yeah, that's terrible writing. I'm sorry.
I like it.
Thanks, Ozzy. Perfectly.
Thank you.
Cuts in two perfectly. Okay, so that's all about. Oh, I've forgotten which one it is. This angle, we're talking about this angle here. It's equal alternate, it's equal size to this. Oh, I better double check before I say it wrong. This doesn't look right, hold on. Oh, yeah. Okay, so alternate angle. So this creates from kind of like our alternate angles in when we deal with transversals. This angle is equal to this, because if we kept this line going, which we don't, these are actually on opposite sides. And where's my other color? Blue. This one equals this one. So alternate angle segments, that's all it says. Alternate. Are equal. So the blue here equals the blue. So when this triangle hits this tangent, the blue equals the blue and the black equals the black. So So yes, you will notice I've done none of the proofs here. I haven't proved any of these. That's very much on purpose so that we have everything all at once in your notebook. So when you check your notes and you have a circle theorem question, they're all there at the same time. You do not need to know how to prove any of them either, so that's good. Perhaps on a different day we'll prove them, but we just want to use them today. So let's use them. I skipped a bunch of questions at the start, so we're going to go back and do those questions now, leaving these up. Okay, so let's go back through these and not ignore them anymore and get some answers.